Hi, in this video we're going to look at a fourth example involving impulse and the change in momentum and how to solve these problems. So remember, it's helpful to try to think through these yourself and work through them with me, pausing the video to challenge yourself and try to think ahead of me. But I'm here to help you if you need that extra help. Our problem says the jet engines on a 450 kilogram airplane cause the plane to accelerate on a runway from 2.0 meters per second to 32.0 meters per second in 80.0 seconds. What is the impulse delivered to the airplane? Let me draw the situation here so you can see my art skills at work. So here's the airplane, and here's the runway. Okay, and there's the wheels, and we have the jets moving on it. So this is the before, and I want to go ahead and label the speed that it was moving at before. So at the beginning, it said it was going 2.0 meters per second. All right, and then I'll draw my after picture. Okay, so now it's moving a lot faster. Okay, and the speed is now 32.0 meters per second. The mass of the airplane, did it give us that? It did. It's 450 kilograms for the mass up here. So I'll just label that on my chart or on my picture. Okay. So now I'm going to start just writing down, identifying the things that I know about the airplane and its motion. It helps to identify just the math symbols that go along with this. It saves us a lot of mental effort later if we can identify that these quantities represent mass, initial velocity, and final velocity. And this just corresponds with my pictures. So mass is 450, initial velocity 2, final velocity 32. We're also given a measurement in seconds, and so we know that's a time measurement. So the time that this happens in is 80.0 seconds. And the big question here, I thought it was force. It says, what is the impulse delivered to the airplane? So we want to know impulse. So to find the impulse, we're going to look at our big equation up here that I've written in blue at the top here. This is our big long equation that has all the different possible variations and variables involving the relationship between impulse and the change in momentum. We're going to be looking directly for the impulse here. We don't need the force or the time. We need the impulse. And so I'm going to write that down over here. Impulse is one of the quantities we are looking for. And then we can choose one of these other quantities that meet the requirements of our problem to help us solve for impulse. It'd be nice if we could use this one, force and time, because it's pretty simple, but we weren't given a force value, so we can't really use that one. It looks like the one we're going to have to be using is this one right here, the change in momentum, which is mass times final velocity minus mass times initial velocity. So that's our equation that we're going to be using for this problem. Now it's just a matter of substituting in our numbers. So the mass is 450 kilograms. The final velocity is 32. And then the initial velocity was just 2. Oh, oops. All right, so now we're ready to start doing the calculations. 450 times 32.0 is 1,000 or 14,400. We're going to round that to have two significant figures. So 14,000 Newton seconds. Usually we give our impulses in Newton seconds. And then 450 times 2.0, that's going to be 900 Newton seconds. Now, technically, we need this 900 to have two significant figures. So to do that, we would ordinarily just write it with scientific notation and write it as 9.0 times 10 to the 2. That way it has two significant figures, but in this case, we're just going to subtract it anyway, and it'll go away. So we're going to do 14,000 minus 900, and we get, 13,100. I guess I could have done that in my head. But that's what we get for our answer, 13,100 Newton seconds. So that is our impulse applied to the plane. So that's all I've got for you in this video. Remember, a bad attitude is like a flat tire. You won't get anywhere until you change it.